Another teardown video. This time it's a B&K again. Electronic Voltmeter type 2409. I've been doing a little bit of research and Googling this type number, and then a radio museum comes up with schematic and information and stuff, and it looks like it's from 1959, and it also contained tubes and a few diodes. It is very, very heavy. Let's look on the back, and you find this really, I think this is American style, so that is a little bit odd. And voltage selector, a lot of different voltages, fantastic, and made in Denmark and so on. Also there's, maybe this is a calibration adjustment and no information about what it is. There was a sticker on the front of the display when I got it. I just removed that, and it says something about defect. So that means what kind of defect is it, like blow up something, or what is going to happen? So I don't expect much. When I look in the schematics, it is very confusing about the on-off switch, because it is not explained in the schematic. The on-off switch should be this one. This is a really weird place to put the on-off switch. Why do you want to have it in the most sensitive range? What if you had already something connected to it and you want to turn it on? So you have to go through the most sensitive. Why don't you have it here, where it's capable of handling a lot of input? And then there's a reference. So that means, I don't know exactly what is going to happen here. So the meter switch, you can turn on and off the meter, and you can go to slow and a UV damping. So that's a slow and fast, I guess, right? So look at that. There's actually a little bit of voltage left in the capacitor in here. I think that is a little bit scary. It's gotta be a lot of years ago since this one was powered up. But there seems to be a little bit of, see? Anyway, let's power it up and see what kind of power consumption there is in this thing. Alright, we are ready to power it up. I turned it down to 220. And please don't tell anybody that I'm doing shit like this, okay? Alright, let's turn this sucker on. 40 watts, 30 watts, 20 watts. This can't be bad. 20 watts. Oi. I was hoping for something in this ref. Huh. Well. Not a lot of nothing, but I didn't put anything in, so we should not see anything, right? But what is this ref? Maybe I should... Well. Let's get some signal and put it in. So if this is volts, RMS, right? 1 volt, full scale. Okay, let's do that. Still, it's not responding at all to input. but power consumption is just getting up and up and up. Slowly but steady. Now it's 47 and it was 20 before, so I think there's a good reason to turn this off and see what is burning hot in here. There's definitely something wrong. There's no reaction on any input, any frequency or any power. I gave it quite a lot of input. So we're gonna open. That was crazy. I think it was corroded a little bit here around the edges. Whew. So there was a lot of bite. Nobody was in here for a million years. Whew. That was difficult. I thought that I missed some screws or something. But finally it let go. And look at the input here. It's shielded. So that is pretty good. Got a few resistors and stuff for the input selector. Okay, so that one is the power on-off switch, and it is nicely shielded. So all the sensitive stuff is behind a metal wall, and then here you got the mains voltage to the transformator and all that. And this is Jensen, I guess, from the color, just like the caps, also Jensen. Yep. That is what I would expect, right? So you see Jensen, Danish brand of capacitors, made in Denmark. What do you think? Let's see. Where's the blown up stuff? Here is something that was hot. As you can tell on the PCB. Single-sided stinky. Yeah, that's a fairly cool track. Nice logo and everything. Names on the different tubes. So okay, yeah, that is a resistor right up against a capacitor. So that is, ooh, it's still a little bit hot. We got some really cute diodes right there. Oh, some more diodes and good stuff for the meter. That is something we know is working, or maybe not, because the meter is just reading a lot of stuff. And here's another power resistor down there. Some more trimmers of all sorts. All over the place we got trimmers. Look at that. There's also, that was definitely a trimmer. The big one here. That is the pot that is accessible from the back side. So, I got an idea. Let's power this up and have a little quick look with the thermal camera. I'll probably be able to tell where something is flying off the scale. It is actually a little bit difficult with the tube gear because you got the really hot tubes. So the range will change in the thermal camera. So that means you can't really easily see if you've got a hot capacitor and stuff. And also look at those power resistors right up against capacitors. Really bad for lifetime. But I guess this wasn't supposed to be having a 60 years life. Well, let's try and see what we got. First of all, I'm just looking for the capacitors, and see, I don't see any hot capacitors or anything bad. All I see is this is their power resistor, the big white one down there. So let's look from the other side. So here's what I did. I powered it up again while measuring the voltages on each side of the ultra hot resistor to ground, because everything is ground related. And I get a lot of voltage on one side and nothing on the other side. And then the other side is connected to a red wire. And this red wire goes to a capacitor. That one. And then I turned everything off and then measure ohm on that capacitor to ground. And we got a 0. So the problem is this capacitor is shorted, or at least something on this net is shorted, right? So what I'm going to do is I'm going to lift this wire from the capacitor and then measure again to figure out where the short is. Thanks again to Radio Museum for schematics. I really encourage you to go to Radio Museum if you want to work with good old tube stuff. But it turns out this model exists in many different versions. And this schematic is far from what I got. Because in the later models, I guess the one that I got is a later model. You'll see the difference. I don't know if you can see this, but look at this tube. This is actually 2 tubes in one. Isn't that nice? So this is ECF82, and this one is doing both of them at the same time. Alright, so they're saving a tube in the later models, like the one I got. So that means everything here is different values and whatnot, but the basic schematic is more or less, it smells a lot like this. And the problem here, this red glowing resistor that I got is this one. So all my voltage just go straight through the cathode follower. This is of course the meter driver. And with all this voltage down here, this one is of course melting hot. Now the voltage is a little bit too high here. This capacitor starts leaking, and this way you get voltage to your meter. Okay, so why is this cathode follower really high? It's high because this one is high, and it's high because there's no current in this one. So this can happen due to other things. Those capacitors can be leaky. So this will be my next move. But it's really difficult to figure out what is what, because none of those trimmers or things, they're not located anywhere where you can easily find them, and they are called something else. They got different values, and it's not exactly like this. And they did actually care to put on some text and stuff on the PCB, but they didn't care to put on numbers or names of any of the trimmers. So how stupid is that? It could have been so easy, but let's make it difficult, alright? So I don't know if I'm gonna spend the whole night screwing around with this one, but we are very close to figuring this out, so I'm probably gonna play a little bit more and see what happens. So in my version, there is a resistor from this grid to ground, and then there is this capacitor that receives all the signal. And this resistor says it's really difficult to read, 3 mega 1.5, but it is like 4.5 mega. So I believe this resistor is a little bit out of spec. So now I'm gonna put in a 3 mega 3.15. So why isn't this shit working? And of course we got filament in both of them. I had the idea the filament could be broken in the pentode part of it. But that is not the case, damn it. God, what a lot of fooling around with all those values and drawing a schematic that is more like the version that I got. But I actually got this circuit up and running now, so now I got all the right DC voltages and everything is fantastic again here. So that is great, and I got signal and all the way in here, but I got a lot of AC here. So that means now I can focus on the two 100 microfarads that I think are not working anymore. And that is actually this baby here. And just a very important note to myself and to everybody else. Look at the red wire. The red one is ground. Shame. And everything bad to you guys who are doing that. You can of course not take a red wire as the ground for your capacitors. What kind of... Ugh, I don't want to have it. But anyway, now we talked about it, now we can remember it, and then I will try with another capacitor and see if it works. I am running a little bit out of ideas because this capacitor measures just as good as another brand new 100 microfarad. I got all the capacitor, oops, it fell off. But I got all the capacity and all the internal resistance and all the good things that you can imagine. It is still there. And so why the heck is it not working? I got a lot of ripple, and that is really weird. Okay, of course it is a single rectifier, but it's supposed to work like this, right? This is how it's designed, and I don't get it. Why is it not working? Shit, man, I need to put this back then. I just went to pick up another one. And this is, of course, the other version with 3 tubes instead of 2. So this model got an integrated pentode triode in one, and this one got them in 2 separate tubes. So I had the idea this was actually the older model, right? Wouldn't you kind of figure that out like that? But listen, if this was the oldest model, why would you have the hole in this metal plate as is needed in the newer model? So it has to be the other way around. Okay? So this is the oldest model with only 2 tubes, and they found out that it's better to do it with 3. And that is why you have the hole here. So this is the newer model. And also, the PCBs look a lot different and more modern. Look here. I don't know what is newest when you look at the PCBs, right? Wouldn't you say this is maybe a little bit smarter? All the tracks are a lot shorter because they're round like that, right? And this model, the PCB is the same as the schematic you can find on Radio Museum. So this is called XC0228, and this is XC0001. So I don't know, it looks like this is the older because it's a lower number. I don't know about numbers really. Also there's an earth connection. You didn't have that in the other one. And maybe this piece of metal has also been used for other products, because you see other holes. That could also be. But all the placements of different parts, it's all very much. Let me show you guys this side by side. Everything is very, very similar. Don't we see any? Oh yeah, type number 8926. 8926B. Huh. I don't know about that. Anyway, it was exactly like I said. This fantastic 2-in-1 tube is defect. It is capable of doing some sort of a DC parameters, but it's not doing any gain. It's really weird. So I put in another one. A new one. And look at that. Ooh, we got signal. So yes, of course you can repair all sorts of stuff, yeah. See, it's very sensitive here, and if I go up and like, see, less sensitive. Yeah, repaired. Oh yeah. Thank you for watching.